Hey students, today we're talking about Hess's law. Hess's law is the law of summation. We'll kind of get to that in just a couple of seconds. Page 7.8, page 286 through 89, and there is some homework today. So here we go. Hess's law is basically about manipulating the delta H. For me, it's just like manipulating a chemical reaction, so hopefully you also feel that same way. So let's kind of jump right in there. So here we are on the first one. It said if a chemical reaction is multiplied by some factor, then the delta H is also multiplied by that same factor. That's kind of like what we just saw in that last one with the stoichiometry part. We multiplied by 2, or if I have twice as much gas, I can go twice as far. So let's look here. All right, so our first reaction, we've got A plus 2B gives us C. Now we've doubled that, so delta H2 would be equal to 2 times delta H1. Notice how we have twice that. All right. As we saw in the reactions before, if you flip it, we can reverse a reaction. Our delta H will change the sign. So looking at that same generic equation, A plus 2B gives us C, delta H1. So if we flip it and have our products, our reactants, we get the delta H2 is equal to negative delta H1. All right. Now, this is where Hess's law comes into play. This is that third one there. If we have an equation that can be expressed as a sum of steps, then the delta H will be the sum of those steps. So this is called the law of summation. And basically what we're doing is we're adding up reactions. All right, so we add up reactions to get it. It's kind of like what we did with kinetics, except this time we're talking about heats of reactions. So let's take a peek here. All right, unfortunately, no, there we go. So, yeah, we have this reversed, and so we just, yeah. And so obviously this is the same example, kind of. We just flipped it, so this would be equal to negative delta H1. We have a real life example in that next one, so let's kind of see what that looks like and see if that helps us explain this a little better. So we're trying to find the delta H for this reaction. All right, and we're trying to use these three bottom reactions to get there. So let's take a look. Here's how I do it. You can kind of find your own way, but hopefully it's kind of some similar method, because hopefully I'm doing it the easy way. All right. So we have C3H8, right? I find that, I see that up here, and I'm like, okay, so it's a product, and I need a product, and I need one of them. So I need to reverse this reaction. So I'm going to put a -1 out front, so it reminds me to reverse that reaction. I'm also going to write that reversed reaction down below, because as it gets a little more confusing, sometimes you'll have very similar things, and you'll want to make sure you've summed up to the correct reaction. So we have this right here. And yes, state symbols are important at this point. You'll see that in maybe a quiz question or something along those lines. Okay, so let's look at that next reaction. I'll change colors here. We've got C plus O2 gives us CO2. Ooh, we have C's here. We have 3 of them. We only have 1 here. So if I multiply this by 3, all right, then I'll get the right thing. So I get 3C solid plus 3 O2 gas. We get our arrow, and we get 3 CO2 gases. And I should also do that with my delta H. I didn't do that on the previous one, and I'll work on that. 3 times negative 393, because what I did to the reaction, I have to do to my delta H. All right, so we've got that. Let's go back to pink for just a second. And we need to reverse that reaction, right? So we're going to have a positive 2043. That's not a 3. There we go, kilojoules. All right, with me so far? Awesome. Let's do that last reaction and kind of see where we're at. So we have 2H2 plus O2s. H2, H2. I need to double that reaction. Right, I need to double this one to get my 4 H2s. So I'm going to have 4 H2s, gases, plus 2 O2s. Remember, I'm doubling everything. And I get 4 H2O, also gases. All right, so delta H here, we have doubled, so we're going to take 2 times that negative 483.6. All right. So let's make sure we got to the end product that we were supposed to get to make sure we've done this right before we do our summation. All right, so just like in our practice previously, we need to check these things out. So if I look, 3 CO2s, 3 CO2s, they cancel out because they're on the opposite sides. 4 H2Os, 4 H2Os, those cancel out. 5 O2s, I have 3 there and 2 there, so that cancels out. And it looks like what I'm left with is hopefully 3 C solids plus 4 H2 gases gives me C3H8 gas. Is that what I was supposed to get? Yes, it is. So now I can do my math here. So we've got a positive 2043 plus we've got 3 times a negative 393.5 and then plus 2 times a negative 483.6. All right, and let's see if that gets us our answer that we're supposed to get. Ooh, look at that. We get delta H is equal to a negative 104.7 kilojoules. And that's correct. And we're right on sig figs too. Rock on. And there you go. There's your answer. All right, see you next time.